Okay, here are the answers to the homework from lesson 13-1, page 933, 935, numbers 13 to 23, and 30 to 32. So, Ms. Wiskevich, if you would pause the video here so that the students could check their answers, that would be good. Okay, lesson 13-2 is about angles of rotation. So we're going to talk about specifically about angles on the coordinate plane, what happens with angles, and rotating them around the coordinate plane. And then we're going to talk about how that relates to our trig functions also. In lesson 13-1, we investigated trigonometric functions using acute angles and right triangles. The trigonometric functions can also be evaluated for other types of angles. And these are very important that you understand these and pay attention to how these work. Okay. We've got an angle in standard position is in standard position when its vertex is at the origin and one ray is on the positive x-axis. So we're always going to look at them to where they look like this, that we have our initial side is on the positive x-axis. That's where the angle starts, or where it begins, and the terminal side is where it ends. Now, if it's a positive angle, we rotate counterclockwise, so you can see that the arrow here rotates around counterclockwise for this positive 135-degree angle. To where over here we have a negative angle, and the angle rotates clockwise, right? It goes down and around like this. So clockwise gives us negative angles, and you could go around many times, it's not just necessarily once, where positive angles go counterclockwise. Reminder that the degree of an angle can be anything really, but normally our circle goes 360 degrees in the positive direction, or negative 360 degrees if we're going in the negative direction. Right? Angles can go around more than one time. So if you look at this angle here, this 390-degree angle here, you'll notice that this blue line here goes all the way around once, plus it goes an additional 30 degrees there to get the angle of 390 degrees. And so an angle of rotation is formed by rotating the terminal side and keeping the initial side in place. So you can go around more than one time. Here it shows just one time around plus an additional 30 degrees, get 390 degrees. So we're going to look at, our first example is going to be drawing angles of rotation. And so here we have three angles, 320 degrees, negative 110, and 990 degrees. So for the 320-degree angle, we need to, first of all, it would help us to make sure we know where each section is at. So we have, this is positive 90, positive 180, positive 270, and positive 360, or 0. Okay. So to get an angle of 320 degrees, we're going to go between 270 and 360. So it would be, we'll go around counterclockwise because it's positive, and that's a little bit closer to, a little bit more than halfway, a little bit closer to 360 than 270 degrees, and we would call that a positive 320-degree angle right there. All right, now notice there's an arrow there. If you don't have an arrow, we don't know which direction it goes, so you need to make sure there's an arrow there. So here, negative degrees, okay, so this is negative 90 would be down, same as where 270 is in positive. Negative 180, same as where positive 180 is, and negative 270 would be up here, and this would be negative 360 degrees. All right, we'll talk about something called coterminal angles, which is part of the reason why those match up. Positive 90, negative 270, positive 270, negative 90. So a negative 110-degree angle, so this is 0 or negative 360, that's a little bit more than 90 degrees. So we'll go a little bit past the 90, and that would represent negative 110 degrees. Now make sure you have an arrow, that this is a ray, so that means it goes on forever. And this is also has an arrow here, So I show which direction the angle is going. All right, the letter C, we have a positive 990 degrees. So positive 990, we know that it's 360 all the way around, one time. So if I go around one time, I've gone 360. Go around a second time, I've now gone 720 degrees. So to figure out where to end up with my 990 then, so if I take that and I subtract 720 degrees, because that's 2 rotations, a third rotation, would that be more or less than 990? No, we can subtract to figure that out. 990 minus 720 is equal to 270 degrees. So that means I've got to go an additional 270 degrees. And if you look back over here, here we have 270 degrees is exactly the axis that goes down. And so we're going to continue this angle around till we get to the negative y-axis, and that would represent 990 degrees. So the other thing you could do is that you could just keep subtracting 360 degrees also until you get to a number between 0 and 360. Okay. Right. So here's drawing angles. So why don't you take a minute, take a couple minutes, and draw these angles here. 210 degrees, 1020 degrees, and negative 300 degrees. And so, Mr. Muskevich, if you would pause the video here, and then I will put the answers for these up so the students can see whether they've done them correctly or not. Okay, so there are the answers to that. Check it out. So your drawing should look like that. Should show the same amount of times around, plus the angles and the arrows that go with them. All right. In example 2, we're going to talk about what's called coterminal angles. And coterminal angles, there are angles that terminate on the same spot. So when I draw the terminal side of my angle, it's actually at the same spot as an angle that is 360 degrees different than that, or multiples of 360 degrees. So for instance, here they show you an angle of 120 degrees in blue, positive 120, and the angle of negative 240 degrees in green. And you can see that these two angles actually terminate at the same spot. And the reason that is because they differ by 360 degrees, because if you go around the circle one time, it's 360 degrees. Now we could continue to add to that. I could add 360 degrees to the 120, which would be 480 degrees, and that would also be coterminal, because that would just mean that I would go around one time plus that 120 degrees. Or we could subtract another 360 degrees here, and where we get negative 600 degrees. And so if I went green-wise, if I went all the way around once, and then back around to here, that would be equal to negative 600 degrees, which all of those terminate at the same spot, so we call those coterminal angles. So coterminal angles all differ by adding or subtracting multiples of 360 degrees. So here, for example 2, we have this 65-degree angle, and they want us to find a positive and a negative angle that are coterminal with that. So all we need to do is either add or subtract 360 degrees to it. So to find my positive angle, I'll take 65 plus 360, which is 405 degrees. Okay? That's coterminal to the 65-degree angle because they differ by a multiple of 360. Negative angle I could take 65 degrees and subtract 360 and get negative 295 degrees. So coterminal angles just differ by a multiple of 360. So I could subtract 360 degrees twice here and use that negative angle, or I could have added 360 degrees twice to get the positive angle. It's basically up to you, but you just have to find a positive and a negative. Okay? Letter B. Here we have an angle that's 410 degrees. Okay? So we need to find a positive and a negative angle that are coterminal with that. So we could do the same thing for a positive we could add 360 degrees. So we get 770 degrees. That would be a positive angle. Now to find our negative angle, all right, we can subtract 360 degrees. And now that equals 50 degrees. Well, that's still positive. So actually, I could have used either one of these two to find my positive angle. So to find my negative angle, then I'm going to need to subtract 360 degrees again, because the 50 degrees obviously is not negative. So my answers here would be negative 310 degrees could be my negative angle. And then I could use either 50 or 770 to be my positive angle. So coterminal angles differ by 360 degrees or multiples of 360 degrees. So why don't you do just do B and C in this case? B and C. Okay, so here for letter B, 500-degree angle, you could have positive ones of 860 or 140, and a negative one of negative 220. And for the 120-degree angle, you could have a positive 240 or a negative 480 degrees. Okay. Reference angles. Reference angles are positive acute angles formed by the terminal side of your angle and the x-axis. So all reference angles are going to be less than 90 degrees because they are acute angles, and they have to be positive. So wherever the angle is, wherever it terminates, I want to go from that spot to the x-axis and find that angle. And that'll tell me what the reference angle is. So let's look at these examples. 135 degrees. So 135 degrees is right here. Here's my 135 degree angle. So what I need to find for my reference angle is I need to find this angle here. So the question is how far is 135 from the horizontal axis? Well, the horizontal axis in this case is at 180 degrees, or the x-axis is. So my question is how far is 135 from 180? And I can subtract. So if I do 180 minus 135, we get 45 degrees. So the reference angle for a 135 degree angle is 45 degrees. Negative 105 degrees. So negative 105 degrees, here's negative 90. Then go a little bit farther past that. Here is negative 105 degrees. So the question is, for the reference angle then, that reference angle is this angle here, this red angle. And how far is that red angle from the x-axis? So how far is negative 105 degrees to this x-axis? Well, In this case, it's negative 180 degrees. So how far is 105 from 180? So if I subtract them, okay, that difference, or find that difference between, so all I need to do is find the difference between 105 and 180. So 180 minus 105 is 75 degrees. So in this case, our reference angle is 75 degrees. 325 degrees. 325 degrees is in the third quadrant. So it's an angle right here. Or it's in, excuse me, the fourth quadrant. Okay. Reminder of the quadrants: 1, 2, 3, and 4. Okay. 325 degrees is in the fourth quadrant. So we want to know how far is 325 degrees from the horizontal axis, which would be 360 degrees. So I can subtract them. 360 minus 325 is equal to 35 degrees. So the reference angle here is 35 degrees. Now notice, in each case, it's a positive angle. All right, depending on which quadrant it's in. Question letter A, it was in the second quadrant. So I have that angle is between, it's between the angle and the negative x-axis. For angle B, it was in the third quadrant, so we can see where that reference angle would be. And in letter C, positive 325 degrees, that's in the fourth quadrant, so you can see where it is. So all of those angles in the second quadrant here, between the terminal side and the x-axis. Third quadrant, from the terminal side to the x-axis. Fourth quadrant, from the terminal side to the x-axis. How far is it? And that is our reference angle. So here are your, here's a check it out. And go ahead and find the reference angle for each one of these three. So go ahead and pause it for just a moment. Okay, so there's the answer to those check it outs. And you don't have to draw a picture like I did in these, but it probably will help you to draw that picture. So, okay, last example then. Right. To determine the value of trigonometric functions for an angle in standard position, first we can begin by selecting a point where the coordinates x, y, and the terminal side of the angle. So what we're going to do is we want to find, okay, so we've got a point, and we want to find sine, cosine, and tangent relative to that point. So we're going to find all three of them, or maybe all six of the trigonometric functions, which it looks like we're going to do for letter A. So now there's two ways to look at this. One way is by graphing it and figuring it out, or also you can just use the information they give you from the formulas. So here we have our trig functions when it relates to a point. So if I have the point xy on the terminal side of theta in standard position, r so first of all, we have to find the hypotenuse. So if they give us a point, x and y, you can see that from this picture here that y is a vertical distance here. This vertical distance represented by this dotted line, and x is this horizontal distance here. So you notice that when we are drawing this right triangle here, we're actually using the reference angle to do that. And so we've made a right triangle, so we have to find the hypotenuse. The hypotenuse we call r because it kind of relates to the radius of a circle if I drew a circle there. And We can find r by using the Pythagorean theorem, that r squared would equal x squared plus y squared. So then r is equal to the square root of x squared plus y squared, which is also in this box here. So to find sine of the angle relative to that point, we do y over x, or y over r. To do cosine, we do x over r. And for tangent, we do y over x. And these still relate because in this situation, we are actually talking about this angle right here, which means then, for our right triangle, which means that the opposite side from that angle is y, the adjacent side for that angle is x, and the hypotenuse is r. So there's where we have our sine, cosine, and tangent. It's related to still opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, and opposite over adjacent for tangent. And so by using the Pythagorean theorem, we can find the hypotenuse first of all, and then just plugging in y and r, x and r, and y and x, we can find sine, cosine, and tangent. So here we have this point, 6, negative 9, and I'm actually going to get rid of this graph because I don't need it. And what we're going to do is, it says, we have the point negative 6, 9 is a point on the terminal side of Q in standard position. Find the exact value of the 6 trigonometric functions for theta. So if I draw this out, just to get a look, at what it looks like. So we would have the point negative 6, 9. So that is over here. Well, the point negative 6, 9 would be approximately here, we'll say. All right. So if we had this angle that went through that point, then what we want to do is we want to find the 6 trig functions that relate to that. So we could think of it as a right triangle here using the reference angle here to find this, where x, or the horizontal side of our right triangle, is negative 6. The vertical side of the right triangle, or y, would be 9. So now we need to find our hypotenuse, r. So r is found by doing the square root of x squared plus y squared. So we add those together, we get 36 plus 81. So r is equal to the square root of, let's see, that's 117, right? Okay, it'd be great if that was a little easier number to work with, but we can deal with square root of 117. Okay. So the first thing you really need to do you need to graph it? No, you do not need to graph it. If you want to graph it to see where it is, then that's fine, but you don't have to. Then we're just going to plug them in. We know that sine is equal to y over r. So that would be 9 over the square root of 117. Now, if you also should remember that we cannot leave a radical in the denominator, so that means I need to multiply by square root of 117 over square root of 117. So this is going to be equal to 9 square roots of 117 over 9, or over 117. Cosine, then, is equal to x over y, or x over r, which would be negative 6 over the square root of 117. Our value for x is negative 6. So then we would do the same thing there, and we would get negative 6 square roots of 117 over 117. All right. And then tangent of theta is y over x. So that would be 9 over negative 6, which is negative 3 halves. Okay. So there's our three main trig functions, sine, cosine, and tangent. And they want us to do all 6 of them. So cosecant then is equal to the reciprocal of sine. So I go back to the easiest one to work with here, and that would be the 9 over square root of 117, because then I just take the reciprocal of that, square root of 117 over 9. Secant, reciprocal of cosine. Go back to the simplest one, square root of 117 over 6, and that is negative. So make sure you put your negative sign in there. And then cotangent, reciprocal of tangent. Simplified version is negative 3 halves, so that would be negative 2 thirds. So in reality, when you have a problem like this, all you really need to do is find r, and then do sine is y over r, cosine is x over r, tangent is y over x. If you want to graph it so you can see where it's at, you can, but that's not necessary either. Okay, so that's the end of the video then. All right, there is a check it out problem, but we'll go ahead and bypass this check it out problem, so then you can start working on your homework. And here is your homework assignment, is right here for today. Just a reminder that, this is going to be on Facebook, the video too, so if you do need to rewatch it, it will be there for you also.